Okay, so what if the very foundation of how we measure physical reality just started drifting? Sounds like a sci-fi thriller, right? But for decades, this was a massive real-world headache for top scientists. Down in a highly secured vault in Paris, our absolute baseline for mass was quietly changing. Welcome to This Explainer. Today, we're diving into the epic 200-year quest to find universal, unchanging truths in a seriously chaotic world. Because think about it, we rely on measurements for absolutely everything, from your phone's GPS navigation to incredibly precise medical dosages. But how exactly do we define what a second or a kilogram truly is? Here is how we're going to break this down. We'll start with the universal language, check out the 7 pillars, dive into the artifact crisis, look at the massive 2019 quantum leap, scale the universe, and finally take a peek at the future of time. All right, Section 1, the universal language. Out of chaos, a system for all. So picture this. Before modern science, human measurement was a global nightmare. A foot literally depended on whose foot you were looking at. Global trade was a total mess. But the turning point came in 1791. The French Académie des Sciences pitched a radical idea. Let's anchor measurement to nature itself. By defining the meter as a fraction of the Earth's distance, they birthed this beautiful aspiration. For all people, for all time. And you can see this evolution perfectly with the meter. It started as a fraction of the Earth in 1781. Then by 1889, it became a literal physical metal bar. Fast forward to 1960, we shrink down to the atomic realm using krypton-86 gas. And finally, in 1983, we nailed it to an immutable constant, the exact speed of light. So today, the meter is simply the distance light travels in a tiny exact fraction of a second. Pretty elegant, right? Moving on to Section 2, the 7 pillars, the foundation of physical reality. By 1960, the global community formally locked in the SI system, and it is built entirely upon just 7 base units. You've got the second for time, the meter for length, the kilogram for mass, alongside the ampere, the Kelvin, the mole, and the candela. That's it. From just these 7 pillars, every single derived measurement in all of physics is perfectly constructed. It's kind of like the ultimate Lego set for reality. Now, the secret superpower of this whole setup is something called coherence. Basically, this means derived units are formed purely from the base units. No messy conversion factors needed. 1 Newton of force is exactly 1 kilogram times 1 meter per second squared. There are no arbitrary, confusing rules like 5,280 feet in a mile. It is just an elegant, perfectly interlocking mathematical system. Which brings us to Section 3, the artifact crisis. The king is losing weight. Despite all that elegance, there was a fatal flaw hiding right in plain sight. See, for 130 years, the global baseline for mass was a single, golf ball-sized cylinder of platinum iridium kept locked in a vault near Paris. But scientists noticed something absolutely terrifying. That original cylinder was slowly drifting in mass by about 50 micrograms. The literal fundamental baseline of physical reality was changing on us. We knew we had to dethrone this aging king. Relying on physical artifacts, a man-made chunk of metal that could get dirty or scratched, is just way too risky for modern science. We needed a transition from that cylinder to an unchanging fundamental law of the universe, specifically Planck's constant, the foundational constant governing quantum mechanics. Enter Section 4, the 2019 quantum leap, anchoring to the cosmos. This entire crisis culminated on May 20, 2019, with literally the biggest measurement overhaul in human history. The scientific community completely retired physical artifacts. The kilogram was suddenly anchored to the Planck constant, using incredibly complex Kibble balances. The ampere, Kelvin, and mole, all tied to unchanging natural constants. We effectively hardwired human measurement directly to the fabric of the universe. And honestly, the wildest part of this monumental shift is the illusion of normalcy. The entire foundation of science relocated to the quantum realm, yet your bathroom scale didn't change at all. A kilogram of apples weighed exactly the same yesterday as it did today. It was a massive scientific revolution hidden perfectly in plain sight, happening at decimal places far beyond everyday instruments. All right, Section 5, scaling the universe from quetta to quectile. So even with perfectly stable definitions, our universe and the sheer volume of our digital data is expanding incredibly fast. To keep up with what we are discovering, governing bodies approved 4 brand new prefixes in 2022. On the massive end, we now have Rana and Quetta, and zooming into the infinitesimally small, we have Ronto and Quecto, which are absolutely essential tools for cutting-edge quantum physics. To give you a visceral sense of just how huge these scales are, a Quetta is 10 to the power of 30. That is a 1 followed by 30 zeros, 1 non-million. It means we can finally express planetary masses elegantly. For example, the planet Jupiter weighs in at about 2 quettagrams. Just a mind-blowing scale. Which brings us to our final stop, Section 6, the future of time, the looming redefinition. The beauty of the SI system is that it's never really static. Right now, the definition of the second is sitting squarely in the crosshairs of modern physics. It's currently defined by microwave frequencies, but the next generation of optical atomic clocks tick with lasers, which are 100,000 times faster. By trapping atoms in these intersecting laser grids called optical lattices, scientists are hitting 19 decimal places of accuracy. Because of this massive leap, nations are gearing up to formally redefine the SI second by 2030. Now, you might be sitting there wondering, why does a clock that loses 1 second every 30 billion years actually matter to me? Well, think about your GPS. Satellites rely on atomic clocks to triangulate your position. Just a single nanosecond of timing error translates to a 30-centimeter navigation error down here on Earth. So this extreme precision, it's the invisible backbone of modern life, enabling our power grids, telecommunications, and global navigation systems to function seamlessly. Over 2 centuries, we've evolved from using the length of a human foot to physical metal artifacts to the very quantum constants of the cosmos itself. So I'll leave you with this final thought. As our measurements become unimaginably precise and our universe reveals more of its secrets, how will our language of reality evolve next? Thanks for joining me on this explainer, and keep wondering.